Hello grade 11 students. In this lecture we're going to start by a new objective, which is continuity. So we're going to talk about the continuity of a function and the derivative of a function. Let us first start with continuity of a function. If you look at this function continues its way without breaks or jumps. So we can say that this function is continuous because there is no breaks or any jumps that stops or that have any empty value inside it. So the graph can be drawn without lifting the pencil. Why? Look at this figure here. You can see that this function is discontinuous. Why? Because there is like a hole in the function and the function is not defined at this point. So the hole in the function makes the function discontinuous. So we can say that this function is discontinuous function. So we can say that sometimes a function could be discontinuous due to a hole, or it could be discontinuous due to a line that prevents the function from continuing its way. I mean, like if you look here, for example, here we have a vertical line. It's usually the vertical asymptote that stops the function from continuing its way. So we say that this function is discontinuous. But how do I check if this function is continuous or not? By calculation. So if I want to calculate if this function is continuous, I have to find the limit of the function when x tends to a point. It should be equal to this function f of c. So you have to replace the point in the function. You should have the same value. So then you can say that this function is continuous or not. Now let us start talking about the derivative. I know that you already learned this in physics, but we have to practice the derivatives and relate them to our lesson, which is function. So what's a derivative and why it's related to a function? And as a definition, the derivative is the rate of change of the function. So the function, it could be, for example, increasing, decreasing. So this rate of change, the derivative defines it. So as a definition, the derivative is the slope of the tangent to the line tangent to the curve. So the line which is tangent to the curve, its slope is the derivative. So now we have to tell that if a function f admits a derivative, then for all points in the domain, the derivative defines a new function. So the derivative of a function, it's a new function and we call it f prime, and it's called the derivative of the function. Let's start with the first example or the first rule. If we have a function which is k means any constant, its derivative is 0. So if, for example, if we have a function equals to 6, then its derivative is 0. If we have a function minus 99, its derivative is 0. So any function which is constant, its derivative, it should be 0. Now, if we have a function x to the power n, its derivative is n x to the power n minus 1. So as if we bring the power down and we subtract 1 from the power. So we have a function x to the power 4. So the first thing you have to do is to bring the 4 down. So we bring the 4 down and we subtract 1 from 4, we get 3. So the derivative of the function, it becomes 4x to the power of 3. Now we have another function which is x to the power 7. We bring down the power and then we subtract 1 from the exponent, so it's 7x to the power of 6. Also, if we have x to the power 15, we bring down the power as it is, 15x to the power of 14. Now x to the power minus 2, even if it's a negative number, so you bring the minus 2 down, x to the power minus 2 minus 1, so it becomes minus 3. Now, if we have a u prime, we need its derivative. You know that a, it's a constant, so bring it down alone, okay? And we do the derivative of u. For example, if we have 3, okay, 3 into x squared plus 1. 3 remains as it is. Now what's the derivative of x squared plus 1? The derivative of x squared is 2x, and the derivative of 1 is 0 because it's constant. So we have 3 into 2x, which becomes 6x. Now let us find the derivative of the function 5 into 3x squared plus 2x plus 41. 5 is a constant, so I leave it as it is. Now what's the derivative of 3x squared? It's 6x. Why? Because we bring down the power. When we bring down the power, we have already 3. 3 times 2, 6. X plus, what's the derivative of 2x? It's 2. And what's the derivative of 41? It's 0 because it's constant. Now we multiply the 5. 5 times 6 is 30x. 5 times 2 is 10. Let us continue. Now we have u plus v prime. This is, we separate the prime for each one alone. So u prime alone and v prime alone. It's an easy example. So we have 2x cubed plus 5x squared. What do I do in this case? I do the derivative of the first one alone and the derivative of the second one alone. So what's the derivative of 2x cubed? It's 6x squared. What's the derivative of 5x squared? It's 10x. Now I advise you, if you solve this one alone, and if you have any problem, of course you can ask me.